You know that box in your kitchen, the one that reheats your leftovers in like 2 minutes flat? Well, it has this absolutely wild secret history. We're talking top secret World War II tech, a melted candy bar, and yeah, an exploding egg. Let's dive into the story.
So that's the big question, isn't it? How in the world did a critical piece of a weapon end up in pretty much every single kitchen on the planet?
Well, our story doesn't start in a kitchen with a chef. Nope. It starts on a battlefield with soldiers. We've got to go back to the Second World War, a time when, the fate of nations was literally hanging in the balance.
So the key to this whole story is this one device. It's called a cavity magnetron. Now, it was developed back in Britain in 1940, and it's basically this high-powered vacuum tube. But here's the thing. It was the secret sauce for making these compact, super powerful radar systems. The kind that could spot enemy planes and submarines with just, unbelievable accuracy. It was a total game changer for the war.
Now, just how important was it? I mean, seriously. Well, an American historian later called it, and I quote, the most valuable cargo ever brought to our shores. Think about that. That's how critical this little device was. We're talking top secret tech that really did help turn the tide of the war.
Okay, so we have this top secret piece of military tech. How does it go from winning a war to cooking our food? Well, it all kicks off with the legendary chocolate bar incident, a really sweet and totally accidental discovery.
And this is where we meet our hero, Percy Spencer. Now, this guy was a brilliant, self-taught engineer. He was working for the American company Raytheon back in 1945, and their whole job was basically to mass-produce these magnetrons for the war effort.
All right, this is where the magic happens. So one day, Spencer is standing in front of a live, active radar set, and he notices that the candy bar in his pocket has just completely melted. Now, he's nowhere near a stove or anything hot, so he gets super curious. He grabs some popcorn kernels, holds them up to the machine, and bam, they start popping all over the lap. So for his next test, he tries an egg, which, promptly explodes right in a colleague's face. And in that, very messy moment, Spencer realized these microwaves could heat food, and they could do it incredibly fast.
Okay, so an exploding egg makes for a great discovery story, for sure. But how does this thing actually work? Well, it's not magic, it's just pure physics.
So the fancy scientific term for this is dielectric heating. And what that means, essentially, is that the microwaves coming from that magnetron are a kind of electromagnetic radiation. They're specifically looking for polar molecules to mess with. And guess what the most common polar molecule in our food is? Yep, it's water. Okay, here's a really simple way to picture it. The microwaves make the little water molecules in your food vibrate and spin around super fast. They're basically trying to line up with this constantly changing electric field. So you can think of it like the microwaves are making them dance. And all of that movement, all that friction, that's what creates the heat that cooks your food. Now, this leads to probably the biggest myth about microwaves. I'm sure you've heard it a million times, that they cook food from the inside out. Turns out that's not really right. The reality is that the microwaves only penetrate and heat the outer layer of the food, maybe about an inch to an inch and a half deep. And from there, the heat just travels to the center the old-fashioned way, through conduction, just like in a regular oven.
All right, so Spencer has made this wild discovery. But how do we get from an exploding egg in a lab to that little box on your countertop? Well, it was a pretty long journey, and it all started with a machine called the radar range.
The first commercial model at the 1947 radar range was, well, it was an absolute monster. I mean, this thing stood almost 6 feet tall, weighed 750 pounds, it had to be water-cooled, and it cost what would be about $35,000 today. When you put that side by side with a modern microwave, wow, the technological leap is just staggering.
But once the technology finally got smaller and cheaper, especially in the late 70s, it just completely took over. Get this, in 1971, only 1% of households in the US had a microwave. Just 1%. By 1997, that number had skyrocketed to over 90%. That's a complete kitchen revolution in just a little over 2 decades.
All right, let's wrap this up by tackling some of the most common myths and, let's be honest, worries that people still have about microwaves today.
Okay, this is the classic one, the one everybody wonders about. Is it actually dangerous to put metal in a microwave?
Well, the truth is, it really depends on the shape of the metal. If you've got something pointy, like a fork, the electric field can get concentrated right at the tips. That's what causes those sparks to fly. It's a process called arcing. But what about smooth metal with no sharp edges? That's actually usually fine. In fact, you can even use little smooth pieces of aluminum foil to shield parts of your food so they don't overcook.
All right, how about this one? You hear it all the time. Does microwaving your food just destroy all the nutrients?
This might actually surprise you, but often the exact opposite is true. Look, any kind of cooking is going to reduce some nutrients, but because microwaving is so fast and uses way less water, it can actually preserve more of those water-soluble vitamins compared to something like boiling. So for example, you'll hang on to more of the good stuff in spinach if you microwave it instead of boiling it where all the nutrients just leak out into the water.
And finally, let's tackle the big one, the one that really freaks people out. Do microwaves leak dangerous radiation?
Okay, you can definitely rest easy on this one. Your microwave is basically built like a tiny fortress. It's a shielded box. It's called a Faraday cage, and it's designed specifically to keep all those waves inside. On top of that, federal standards are incredibly strict. They limit any potential leakage to levels that are way, way below anything considered harmful. And plus, the radiation itself is what's called non-ionizing, which just means it doesn't carry the same kinds of risks as something like an X-ray.
So there you have it. From a top-secret weapon of war to the humble box that heats up your coffee, the microwave's journey is just a perfect example of accidental genius. And it kind of leaves you with a really fascinating question, doesn't it? What other everyday objects sitting in our homes right now have their own secret, extraordinary histories just waiting to be discovered?